One of the features of the positive flow deaerating cooling system is in the way the system fills with coolant. The cooling system must be able to accept coolant at a rate of at least 5 gallons per minute. Coolant flows out of the reserve tank through the fill line to the engine and radiator. The engine fill line is installed in the rear of the water pump inlet. Flow from the fill line allows the engine and radiator to fill with coolant from the bottom of the system. As the system fills, the coolant pushes the air out of the system through the engine vent line and the radiator core vent tube. After filling the engine and radiator, coolant fills the reserve tank until the coolant level reaches the bottom of the fill neck. The position of the fill neck limits the amount of coolant in the reserve tank. This room in the tank not only leaves room for expansion, but also ensures that the radiator core vent tube remains open. Coolant flow begins as coolant is drawn into the water pump inlet by the belt-driven water pump mounted to the front of the engine block. The phenolic impeller draws coolant into the water pump housing and supplies coolant flow to the engine. The pump produces 62 gallons per minute flow at peak torque with a rated speed pressure of 24 psi. The output from the water pump empties into the coolant cavity surrounding the oil cooler cores. This provides the oil cooler with the lowest possible temperature coolant. As the coolant in this cavity passes around the oil cooler cores, heat is transferred from the oil to the cooler. Coolant passes out the top of this cavity through the small cast openings. From these openings, coolant enters the water jacket area of the block. In the water jacket, coolant travels around the liners, carrying combustion heat to the top of the block. Coolant passages in the top of the block are sized to force most of the coolant across the engine to the fuel pump side. However, small openings on the exhaust side of the engine block allow some coolant to enter the cylinder head from the exhaust side of the engine. Coolant flowing up through the passages in the fuel pump side of the cylinder head gasket flows to the lower water cavity through passages in the cylinder head. This flow cools the valve seats, injector area, and the exhaust ports. This coolant continues its flow across the cylinder head. From the lower cavity, coolant flows to the upper cavity. This coolant helps to lower the temperature of the exhaust ports. The coolant then flows to the exhaust side of the cylinder head, toward the front of the engine, through the return manifold in the cylinder thermostat housing, where it circulates around the sensing bulbs of the thermostats. When the coolant at the thermostats is below 180 degrees Fahrenheit, the thermostats are closed, allowing the coolant to flow through the center of the thermostats to the outboard side thermostat housing cover. From this area of the cover, the coolant flows back through a return passage in the cover and thermostat housing to the bypass passage in the engine block. When the thermostats are in this position, the coolant is directed to bypass the radiator and flow back to the water pump inlet through an internal passage in the engine block. As the coolant temperature increases to 180 degrees Fahrenheit, the thermostats start to open and coolant flow to the bypass begins to be restricted. In this position, some coolant is directed to the bypass and the remainder is directed to the radiator. When the engine operating temperature increases to 200 degrees Fahrenheit, the thermostats fully open, blocking the bypass passage in the thermostat housing cover. When the bypass passage is blocked off, all of the coolant flow is directed to the radiator. The engine must never be operated without either of the thermostats. Without a thermostat, the coolant recirculates, bypassing the radiator, causing the engine to overheat. Coolant returns from the radiator to the water pump through the water pump inlet. With a positive flow deaerating cooling system, water supply to the inlet connection of the water pump is supplied from 3 sources: the bypass passage, the bottom tank of the radiator, and from the fill line. When the thermostat is closed, the pressure in the block circuit causes the supply to the water pump to flow from the bypass passage. When the engine reaches operating temperature and the thermostat opens, the pressure in that part of the circuit causes the flow to come from the bottom tank of the radiator. As the thermostat changes position based on engine coolant temperature, the flow of coolant is modulated between the bypass passage and the radiator to precisely control the coolant temperature. The fill line ensures that there is a positive flow of coolant at the water pump inlet at all times. As the water pump increases in speed, more coolant is needed to increase the coolant flow. When the block and radiator circuit cannot supply enough coolant, the low pressure at the pump draws coolant through the Some of the pressurized coolant from the water pump outlet is directed to drillings in the water pump inlet. These drillings supply coolant flow to the coolant filter. The higher pressure coolant from the water pump flows through the filter and into the lower pressure water inlet. The coolant port toward the middle of the engine block provides pressurized coolant flow to the air compressor. This flow comes from the water jacket in the block. The connection in the block near the gear housing provides for coolant flow from the air compressor. This port connects to the coolant bypass passage. Since the bypass passage is directly connected to the inlet side of the water pump, this area has a low coolant pressure. The pressure differential between the coolant in the block and the coolant in the bypass passage causes coolant to flow through the air compressor.